Okay, so I wanted to go over this review for the test. Now, um, the first thing I want to introduce to you are these theorems, and I know, practically speaking, he's gonna put explain your answer or show your work, and just writing down a theorem like this, AB equals CD, is not gonna get you full points. But really, this is just a way to verify that you got the right answer. And if you don't see that, if you don't have the same answer as if you just did this, then you know you got the wrong answer. Plus, this might be a way of, this might be a way of just getting like half credit, even if you don't remember how to prove it. But I'm just going to go through the motions of showing you guys how to prove it, so that you guys can use this without getting docked off points. So, think back to when we had these kinds of problems, and think of what we did, right? First of all, we constructed these lines, right? And then we first looked at this angle, that this angle is equal to this angle. Similarly, similarly, if we looked at this arc, right, there are two angles that open up to the same arc. This one down here, okay, and then also this one over here. And so we can conclude that those two are equal, right? And then by AAA, they are similar, right? Okay. Now, since we know that the reflection will go something like this, we can do our proportions, right? B over C, this to this, is equal to this to this, right? D over A. Now, one thing we can do, okay, is what if we multiply both sides by A times C, right? And this is just to get rid of the fractions. Note that on the left side, this will cancel with this, and on the right side, this will cancel with this. And then we arrive at our theorem, right? And then us just switch around the multiplication. So AB is equal to CD, okay? That's how you prove it. Similarly, with this one, right? We proved this by first constructing this line and this line, okay? And then we used that this is a shared angle, okay? And then we looked at this triangle and then this triangle, okay? And we saw that if we looked at this arc, right here, both this angle and this angle, right here and here, opened up to it, right? It opened up to the same arc, so therefore we can conclude it's similar. We can conclude that these triangles are similar by AAA, as we have two angles, right? Here and here. Okay? Now we can do our proportion, okay? So I'll first do it across of the double angle, so Y in this case. So in this triangle, right, Y is across from the double angle, right, over, and then of course, let's label this as the triple, right, and this as the triple, and then the side across the triple is this entire side, right, and so Y over A plus B, okay, and then let's look at the other triangle, okay, this would be that triangle. Let's first do the side across of the double angle, so the side across from the double angle is B over the side across from the triple angle, which is X plus Y, okay? Now if we multiply both sides by all of the denominators, okay, X plus Y times A plus B, okay? Times a plus b. Right, on the left side, this will cancel with this, and on the right side, this will cancel with this. So we arrive at our theorem, right? Y times x plus y is equal to b times a plus b. Now, if you have a notes or anywhere where you would do these problems, make sure you write especially the left boxes down, okay? These are very important to be able to do these problems quickly, and after you can prove it, right? So now that I've proven how these theorems work, make sure you understand how these theorems work, but yeah, make sure you can prove it on your own. But from now on, I'll just be using what we've already proven to get these answers fairly quickly. Okay? Another important one is the inscribed angle theorem, right? And this is the famous one. The arc is double the angle, right? Okay. B232. AB is a diameter of circle P. AP is 9. So AP equals 9 is a big fact, as AP is also our radius, right? Now let's look at angle APC. Angle APC is 7x minus 8. I will label that on the picture. Angle BPC, which is this angle, I will note it in green, is 3x minus 17. Find the measure of angle BPC and the length of BC. Okay. So if we have a diameter of a circle, for example, like this, right? We know that it cuts the circle in half, as it needs to pass through the center of the circle. And so we know that this arc over here will be 180 degrees, and this arc right here will be 180 degrees. Okay? Now that we know that this entire arc will be 180 degrees. And since this is a central angle, since these are central angles, we know that this measure, will also be 180 degrees. Okay? And so now we can create our equation. Okay? 7x minus 8 plus 3x minus 17, that will be 180 degrees, right? Combine like terms, 10x minus 25 is equal to 180. 10x is equal to 205, right? Yep. And then x is equal to 205 over 10. And then we can reduce this by 5. This becomes 41 over 2, okay? Now that we know that x is equal to 41 over 2, we can find what we're trying to find for. So angle BPC. Angle BPC is the 3x minus 17. So let's plug that in. 3x minus 17. We know that x is equal to 41 over 2. So 3 times 41 over 2 minus 17, right? Let's multiply 41 by 3. We know that that will be 123, right? Over 2. And then minus 17. We can change the 17 to a 34 over 2, and we could subtract them. 123 minus 34, right? It will be 89, right? 89 over 2 equals our angle. So 89 over 2 degrees is our answer for the for the angle of BPC. Okay? Now the length of BPC will just be a fraction of the entire circle's circumference. Okay? Now, what is the entire circle's circumference? The entire circle's circumference is 2 pi r, and we know from the given information that AP is equal to 9, so our radius is 9. So we can replace r with 9, right? And so that equals 18 pi, which is our entire circumference. But we only want, since this whole entire circle is 360 degrees, the entire arc is 360 degrees, we only want 89 halves of it, right? And so we can do our ratio, right? We have what we have, right? We have what we want over the entire thing, right? And then we want to multiply that by our entire circumference. Now we can cancel things, right? This will cancel this, so this will, on the bottom, will become 20, okay? And then it's 89 over 2 over 20 times pi. If we multiply both the top and the bottom of this fraction by 2, we can get that that is equal to 89 over 40 pi. And yeah, okay. Now let's move to 240. So looking at number A, this immediately tells me that this has to do something with the arcs, right? And because we're given 40 degrees and 120 degrees, and the only missing thing we have is here, I'm just going to go ahead and find what the missing measure of the arc is, right? Since an entire arc has to be 360 degrees, we can just do subtraction, right? 360 degrees minus 40 degrees minus 120 degrees. We know that that will equal to 200 degrees, okay? And so this arc will be 200 degrees. Now, how do we find an inscribed angle if this is 200 degrees? Right, it's just half of it. So this will become 100 degrees. Okay, easy enough. Okay. Now, B is a little bit hard, but first, since we want to find x as it's a measure of one arc, let's just go ahead and find this arc, right? It has to deal with arcs, we know that, since that's what's going to be our answer. And so what would be the measure of this arc? So the measure of this arc would be 88 degrees, right? And since we know that this is, well, actually no, we don't need to. So since we know that this is equilateral, right? Or what if we drew this line, right? Now this becomes a triangle, and we know that this angle will have to be equal to this angle. Let's redraw a triangle over here, and this is 44 degrees. Since we know that in an isosceles triangle that this angle has to be equal to this angle, since they're opposite of the equal sides, we know that the entire triangle has to be 180 degrees, right? And if we call this angle A, right? You know that 180 minus 2 of those angles. 180 minus 44 degrees, right? Has to be those two angles. Now we can do our subtraction, right? This becomes 136 degrees is equal to 2a. Divide by 2, you should get 68 degrees. Okay? Now, what did we just find? We just found this angle, right? 68 degrees. And the funny thing is, we're trying to find what this arc is, right? And if we look here, right, this is actually an inscribed angle. And so, what would be the measure of this arc? Well, double of this number, right? And so it will just be 136 degrees. So x is equal to 136 degrees. Okay, C. So here, we know that this is the diameter since it goes through the center of the circle. Similarly, if we know that this arc is 180 degrees, right, because it's the diameter cuts it in half, if we draw this triangle, we know that this will be 90 degrees because this is an inscribed angle and it will be half of it, right? since we know that the entire circle measure will be 360 degrees, right? 360 degrees. If we minus 180 from it, we know that 180 will be this side of the circle. And we already knew that, right? Now, since we know that this inscribed angle is 25 degrees, how long would this arc be, right? How long would that arc be? Well, it would be double it, right? Because it's an inscribed angle, so this would be 50 degrees, which leaves only 130 degrees left for our x, right? So that will become 130 degrees, and boom, x is equal to 130 degrees. Okay, 243. Okay, if the measure of AC is equal to x squared plus 15, and the measure of BD is 10x plus 26, and the measure of AEC is 3x plus 59. Okay, so this is one of the theorems, right, that I actually didn't put up here, and that's because it's one of the theorems that's kind of like cheating. But here, yeah, so here, I will just copy and paste this over here, right, but bigger. So if we have an arc here of A degrees and an arc here of B degrees, know that this angle, right, will be the average of those two. Now, how do I know that? Well, let's go ahead and prove it, okay? So, right, if we construct, for example, this line and this line, we can now use similar triangles, right? If we look here, right, we know that this will be half of A, and we know that this, right, is an internal angle, that will be half of B. Similarly, this angle will be equal to this angle, and then we can do the same thing. This is B over 2, and this is A over 2, as these inscribed angles open up to the given arcs. Okay? Now, if we have a triangle, right? If we have a triangle, and let's turn this around, right? If we have a triangle, and we are given, for example, that this is 18 degrees, and this is 12 degrees, and we want to find this angle, if we remember back to earlier in geometry, we learned that this angle plus this angle, so 18 plus 12, is equal to x. Now, how can we prove that? Well, first, let's find this angle, right? And we know that this angle will just be the entire, this will just be 180 degrees minus 12 degrees minus 18 degrees, right? Because a triangle has to add up to 180 degrees. Now, since we know that this is a straight line, right, this angle has to be the complement of it. So, this has to be 180 degrees, right, because it's a straight line, minus whatever this angle is, okay? So 180 degrees minus 12 degrees minus 18 degrees. Now, if we distribute this negative, okay, distribute the negative, we will get 180 degrees minus 180 degrees plus 12 degrees plus 18 degrees, okay? Note that these two cancel, and we're just left with 12 degrees plus 18 degrees. Now, what was 12 degrees and 80 degrees? These two angles, okay? So we have just proven that this plus this equals this, right? Okay, now we can use it here, right? Since we have this angle and this angle, we know that that has to be equal to this. So we get that x is equal to a over 2. Let me switch colors. A over 2 plus b over 2. Now we can generalize this as just the average of a and b. Okay? And boom, I've just proven it too. Now how do we use this in this problem, right? Let's go ahead and label it again. X squared plus 15. This is 3x plus 59. And BD is 10x plus 26, right? We can just use our theorem. In this problem, this would be our x. So 3x plus 59 would be the average of these two. Okay? Now what is the average of these two? It's just x squared plus 15, right? You add them, plus 10x plus 26 all over 2. Now we can go ahead and multiply by 2 on both sides to cancel this fraction. Okay? And so on the left side we get 6x plus 118. Okay, is equal to x squared plus 15 plus 10x plus 26. Collect all of it on one side, so 0 is equal to x squared plus 4x. Now, if we combined this and this, we would get 41, and then minus 118. 118 minus 41, 7, 11, 7. So this would be minus 77. Okay? Now we can factor this as x plus 11 times x minus 7. Okay? And then we get that x is equal to negative 11 or 7. We know that x cannot be a negative number, and so x is equal to 7. Now, make sure you answer the question. Find the measure of AEC. AEC is 3x plus 59. Angle AEC is equal to 3x plus 59. And since we know that x equals 7, 3 times 7 plus 59, right? This becomes 21 plus 59, which is equal to 80 degrees. And that is our answer. Okay. B244. Let's go ahead and label all that we know. If M is the midpoint of AD, we know that this arc and this arc will be the same because it's the midpoint, right? Okay, now if we go to ABM, this is 6 times x minus 2, quantity, okay? And MCD is 3 times 15 minus 2x. BMC is, I'm going to draw an arrow, 100 minus 8x. Okay? Now, since we know that this arc and this arc is the same, we can conclude that these two angles are the same, right? Because it'll just be half of them. So we can set them equal to each other. 3 times quantity, 15 minus 2x, is equal to 6 times quantity x minus 2. Distribute. On the left side, this becomes 45 minus 6x. On the right side, this becomes 6x minus 12. Collect that. If we add 6x on both sides, and then we plus 12 on both sides, we get that 12x on the right side is equal to 57. If we divide, we get that x is equal to 57 over 12. Okay? Now, it's asking for the measure of BC. Now, how would we find that? Well, we have this central angle. Sorry, we have this internal angle. And so, right, we have this, so 100 minus 8 times x, right, which is 57 over 12. And this is B, and this is BMC, right? Okay, now if we simplify this fraction, we can reduce by 4, so that on the top it becomes 2 and the bottom it becomes 3. Okay, similarly 57 over 3, we can reduce that again. This becomes a 1, and the 57 becomes 127, 9, right? It becomes 19. On the right side, it's this 100 is still 100, but 2 times 19 is 38, right? And so angle BMC is equal to 62, right? 62 degrees. But we want to find the measure of BC, right? And since this is half of it, we can times it by 2, and so we get 124 degrees. That is our answer. Okay, now we can finally use what we learned up here, right? So I don't like to memorize just the letters, right? Because A, B, C, and D. What is A, B, and C, D, right? So I just look at it in terms of this, right? In terms of what's actually on the circle, right? So I memorize it as this times this, okay? This times this, okay, is equal to this times this. And in this problem, okay, this is x, so x times this is also x, so x times x is equal to 3 times 15. 3 times 15. So that means x squared is equal to 45. We can square root both sides, and x is equal to 3 root 5, right? Because 45 is equal to 9 times 5. And when we square root that, we can change that into the square root of 9 times the square root of 5, which is equal to the 3 times square root of 5. And that's our answer. Similarly, for B, if we do this times this, okay, I'll do this in green. This times this is root 10x, okay? And then this times this is 4 root 6. Now if you divide both sides by root 10, okay, this will cancel. And then you get x is equal to 4 root 6 over root 10. If we multiply both the top and bottom by root 10, okay, the bottom will become 10 and the top will become root 60. If we reduce this, this becomes 2, this becomes a 5. So it becomes 2 root 60 over 5. You can also simplify this, and so we can take out a 2, or a 4, right? And so this becomes 4 root 15 over 5. And that's our answer. Okay. So now you guys can see how fast doing it with my method is. So all you just have to remember, right? This times this on the same line, this times this on the same line is equal to this times this on the same line when it's inside of the circle. When it's outside of the circle, it's basically the same thing, but the problem is it's outside of the circle, right? So it becomes this times this entire thing on the same line is equal to this times the entire thing on the same line. Now you have to be careful with this, because they're just going to give you this is y and this is x, right? And so this entire thing is x plus y. It's not just x, okay? So make sure you note that down, x plus y. Now if they give you the entire thing, like in this problem, then it will just be 3, which is this, times the entire thing, which is x, right? But if we look in the A problem, it doesn't give us the entire thing. So this entire thing will be this plus this. So x plus 8. Okay? But we can just do that in our head. So we get the small side, x, right? X times the entire thing. So x plus 8 is equal to 3, right? 3 times this entire thing, which becomes 16. Multiply it out, x squared plus 8x is equal to, right? This becomes 48 minus 48 on both sides. X squared plus 8x minus 48 equals 0. Okay, now think of the factors of 48. One that could work is 12 and 4. And so we can factor this as x plus 12 times x minus 4 equals 0. We get that x is equal to 4 or negative 12, but we know that negative 12 doesn't work. So x is equal to 4, and that's our answer. For this one, we can do the exact same thing. 2 times 2 plus 10, so 12. The entire thing is equal to 3 times the entire thing, which is 3 plus x. Okay? On the left side, it becomes 24 is equal to distribute. Okay? 9 plus 3x. We can minus 9 on both sides. Okay? On the left side, it becomes 15 equals 3x. Divide by 3 on both sides to get that x is equal to 5. So now you understand how easy it is once you remember these few theorems. Okay? Now I've prepared a few questions for you guys, and then on the bottom it's just find x. So you can try out these problems using the theorems that I've told you and using the things that we learned. These should not be very hard. This is just the practice problems, and repetition really makes this easy. Okay? Repetition in math can help you out on the test when there isn't just a lot of time, right? So try these problems out. If you need help, DM me on Instagram, or yeah, just reach out to me. I might post a video with the answers, but these shouldn't be too hard. Okay. Lastly, I'll go over what you need to know for the test. That's not just these algebra problems. So, one of the things you do need to know is this, right? Know that this angle right here is equal to the average of the two arcs on the left and right of it. Okay? Now, also remember that you need to know what a circumcenter is. So, if we have this triangle, the circumcenter, it's not the incenter, it's not the incircle, and so you know it has to hit all of these, right? And it's a perfect circle, so definitely not what I did, right? So yeah, it'll look something like that. Similarly, if you have the same triangle or something close to it, what is the incircle? Well, the incircle is a circle that's inside of it, right? Now the properties of this is, for the left one, it touches all three vertices, okay? And then on the right side, it's perpendicular to all three sides, and it's tangent, right? Okay. Now, to construct these lines, remember that you have to construct these lines in particular ways, right? For the circle, right? You take the perpendicular bisectors of each, and then you find where they intersect, right? And they all intersect at the same place if you're not bad at drawing, right? For this one, I think you do, oh yeah, you do the bisector of each angle, okay? And it might look something like that, but yeah, you take the bisector. So I'll write it out. So perpendicular perpendicular bisector of all sides, right? And that is the circle. Now for this one, it is the angle bisector of all angles. Okay? And then this is the incircle. Okay, I think that's about it. We can the incircle, sides of 30, 60, 90 triangle, sides of 44, 45, 45, 90 triangle. And yeah, this should be easy for you guys. Good luck, and I'll see you on Wednesday for Takeuchi, and everyone else, good luck. Goodbye.